Now, when it comes to subtraction, not a whole lot changes. I want you to remember something as we progress through this course, that subtraction just means add the opposite. So we could literally just change this to plus -5. And that's really how we want to think about this. This is an addition problem where I got a -5 up there. But I also want to show this example because these denominators look like they're much more complicated. But one of the keys here is to factor them. So let's factor this first one by saying what multiplies to be -10 and adds to be +3. And so that would be x plus 5 and x minus 2. And then similarly, we can factor the x squared minus 4, and that's going to be a difference of squares. That's x plus 2, x minus 2. So once we have these in this nice factored form, now we can look and say, what are we missing? So if we start with the first fraction and look at the second, so we're going to look at the x plus 2, x minus 2. The first fraction already has an x minus 2 in him, so he doesn't need that. What he does need, what he is missing, is the x plus 2. So we're going to put an x plus 2 in the top and the bottom. And again, remember that what's happening here is I'm multiplying by 1. Since I'm multiplying by the same thing in the top and the bottom, anything over itself is 1. So that's all that's going on is I'm multiplying by 1. Now if we look from the perspective of the second fraction and we look at the first one to say, I'm jealous of you, what do you have that I don't have? So he's got an x plus 5 and I don't have an x plus 5. So I want an x plus 5 in the top and the bottom. Now the first guy has an x minus 2, but I have an x minus 2. The first guy has an x plus 2, but I have an x plus 2. So I'm perfectly fine now that both denominators are the same. Now that both denominators are the same, I can just look at the numerators. The numerators are 2 times x plus 2 and -5 times x plus 5. In this denominator, it doesn't matter which order I write those three factors in, but the denominator is going to be those three factors. Remember, it doesn't change when you're adding or subtracting with fractions. Once your denominator is the same, it stays that way. Now we can simplify the top. We're just going to distribute the 2 to get 2x plus 4. We're going to distribute the -5 to get -5x minus 25. And we're just going to rewrite that bottom. I know it's a little tedious to keep rewriting, but we're going to be good little mathematicians and make sure that our steps follow from one step to the next, and that they're equivalent to each other. And now up top, we're going to go ahead and simplify one more step by combining these like terms. What we have here is an acceptable final answer. It would also be okay if we went ahead and factored the top to notice, hey, there's a greatest common factor up there. So it's going to factor this way. And this is not a bad idea to do because what we're going to cover here in a second is simplifying fractions, and to remember that when we simplify, we're going to factor and then divide out any common factors. So either answer is perfectly fine, but the second one does help us to see that this doesn't simplify any further because there's nothing in common between the top and the bottom.